In this video, I'm on number 11 on page 21 in your packet. So the first thing that we're going to do is factor anything that can be factored. So this denominator would be x plus 8, x minus 3. And now I need to cancel anything out that will cancel out. So my x plus 8's cancel. And remember, anything divided by itself is technically 1. So that gives me 1 over x minus 3. All right, so that's my simplified version. Now I'm going to identify my wholes. And since I did have something to cancel out, the x plus 8, that's going to help me get the x value of my whole. So when I set it equal to 0 and solve for x, I get x equals negative 8. Now I need to substitute back into this original or simplified function. So I would have 1 over negative 8 minus 3, which is really 1 over a negative 11, right? Now, it's a little easier to graph as a decimal, so that would be a negative 0.1. So my whole is negative 8, negative 0.1. So I can plot that point on my graph. And it barely goes under the x-axis, which is hard to show that when you don't have a whole lot of space. All right, so the vertical asymptote says to set the denominator equal to 0. All right, so my denominator is x minus 3, and I'm going to solve for x to get positive 3. So at positive 3, I'm going to draw a vertical asymptote. All right, now I need to do the horizontal asymptote. So this is all about top heavy, bottom heavy, or equally heavy. All right, now in this case, I can use either one, but if I look at the original, I have x to the first power, and in the denominator, it's x squared. So 1 is smaller than 2, so that means it's bottom heavy. And if it's bottom heavy, then y would equal to 0 every time. All right, so my horizontal asymptote is at y equals 0. I'm trying to make this a little exaggerated so you can see that better, since it is on an axis. All right, so now I need to get my x-intercept. And it's to get the x-intercept, we set the numerator equal to 0. Well, the numerator is 1. Well, if we set 1 equal to 0, is that even true? No. So that means there is not an x-intercept. Now for the y-intercept, I'm going to substitute 0 in for x. So I have 1 over 0 minus 3, which is just a negative 1/3 or a negative 0.3 repeating. So 0, negative 0.3 would be my estimated y-intercept. So 0 and down a little. All right, so I have a couple of points. Now this side is pretty easy for me to graph. Okay, but I am going to plot some additional points just to kind of help define my graph. Plus, I need to know something about this side. So in my calculator, let's try that again. N over D. So I hit the table button and then N over D. And I'm going to put 1 over x minus 3. I'm going to start at 0, but I could really start anywhere because I can scroll. All right, but I'm going to look for some points that I can plot. So I do have a point at 2, negative 1. So that's right here. 4, 1, which is right here. And a bunch of decimals or fractions. So I'm going to go the other way and see if there's anything else I can plot. But just again, a bunch of decimals or fractions. So this is thankfully enough to sketch my graph. So we know that it's going to approach this asymptote right here. So I'm just going to curve through these points. And then it's going to curve towards this asymptote. And then even though I only have one point here, that's okay because I know that it has to approach the asymptotes. And so that is the graph that I get.